All right, hello, and thank you to everyone for joining the webinar today on the business case for MulteFire technology, an economic analysis of two use cases. Today, presented by the MulteFire Alliance. We're joined by Mazen Chmaytelli, President of the MulteFire Alliance and Senior Director of Business Development for Qualcomm Technologies Incorporated. As well, we are joined by Randall Schwartz, Principal Analyst for Wireless 2020. We'll begin with an introduction into the MulteFire Alliance and MulteFire technology, followed by an economic analysis as well as cost and revenue modeling for two use cases where MulteFire technology could be deployed. At the end of the presentations, we'll have time for Q&A with the presenters. Please submit any questions you have during the presentation at any time, and we will answer that at the end. Also, please note that the webinar as well as the slides will be available after this presentation. With that, take it away.
Hello, everyone. This is Madison Chmaytelli. I'm the president of the MulteFire Alliance. I'm going to spend the next few minutes or so give a background and an update on the Alliance, then hand it off to Randall so he can go through his slides and the topics of this webinar, the two use cases. Okay, Randy? All right, so just a quick refresher on the MulteFire Alliance itself. So the MulteFire Alliance started in late 2015. It was founded by 4 companies initially: Qualcomm, Nokia, Ericsson, and Intel. And we grew to 45 members as of today. The goal of the Alliance was to put together like-minded companies to basically have LTE running in unlicensed spectrum band without the necessity of having a licensed anchor. That's the whole objective initially back in late 2015. So the goal here was to put together a specification in an industry body to go ahead and deploy an end-to-end network based on MulteFire, which is running LTE in unlicensed spectrum. As things progressed, we also looked at additional spectrum bands, such as shared spectrum, which I'll touch on as well. A lot of the development that's been done within the MulteFire Alliance is based on 3GPP specification. However, making sure the requirement is targeted toward running uplink and downlink in unlicensed spectrum band. The key target markets that the Alliance is focused on is Industrial IOT, enterprise, cable industry, as well as additional verticals. And from an availability perspective, if you go to the MulteFire Alliance website, you'll see that release 1.0, which is the end-to-end specification, is already available publicly to everyone to download. We are also working on finalizing the certification program for end-to-end certification of MulteFire products, that's both on the UE side as well as on the small cell. Next slide. Now, I want to highlight some roadmap slide here, what we've been doing within the Alliance for the past 3 years. So as I mentioned already, MulteFire Release 1.0 is already available in 2017. And that's basically leverage 3GPP Release 13 and 14 when it comes to LAA and ELAA. However, made it, targeting the markets without the necessity of a licensed anchor. That's really Release 1.0. What we're busy working on as we speak right now is Release 1.1 of the MulteFire Alliance, which is specifically targeted to IoT applications. So think of it as 3GPP worked on eMTC and NB-IoT in licensed spectrum. The MulteFire Alliance took that effort and applied it towards unlicensed spectrum band. I'll be in China next week for the MulteFire Alliance meeting in Beijing, where the technical team will be finalizing that spec. So we're looking forward for that milestone. As you see, looking forward toward 2019, the Alliance is looking, same thing we've done in the LTE side of the 3GPP releases. We are also looking forward toward 5G releases of unlicensed spectrum opportunities, and the MulteFire Alliance will be working to define how best to commercialize these use cases. Next slide, Ren. So this is a good slide to summarize the various releases we have to date. As you could see, initially Release 1.0 supported the 5 GHz band globally that gives access to 500 MHz of spectrum available worldwide. Of course, the MulteFire Alliance follows the rule needed to deploy in these spectrum band, which is listen before talk, similar to LAA with a licensed anchor. Now, release 1.1 will open up capabilities into eMTC and NB-IoT in additional unlicensed or shared spectrum bands. And I added some details on this slide, which bands were targeted initially. Now, release 1.0 is available publicly back in April 2017. We actually made it available to the Alliance members in January. So there's always a lag between having the release available to Alliance members versus the public. The end-to-end spec is about 16 documents long, and it has basically everything you need from a radio airlink perspective as well as end-to-end architecture. I'm highlighting on the slide 2 deployment models that's already available as part of the specification. One is a neutral host model, as well as a model that's basically enabling private LTE-based deployment models. We are looking at trials toward the second half of 2018 from a MulteFire Alliance perspective, as well as having a certification program defined by the end of this year. Next slide. Now, release 1.1, again, we looked at it as optimized specifically for IoT. It adds additional spectrum bands, such as sub-1 gigahertz, 1.9 in Japan, and 2.4 gigahertz, and also enabling moderate data rate for eMTC and unlicensed band application, as well as narrowband IoT application as well. We are targeting to finalize it in Beijing next week. So I would assume once everything is done on the technical side in mid-October, we'll start the balloting process, et cetera. So release 1.1 will be ready end of this year or early 2019 to the membership base. Okay. We're happy to announce that we're up to 45 members right now. So over the last 18 months, we tripled the membership base. You could see the company's logos on this slide. But I'm happy to highlight that you have basically every key pillar industry within the telecom industry represented in here. So you have hardware manufacturers, chipset manufacturers, infra manufacturers, test equipment providers, as well as MSOs and MNOs represented within the Alliance. So we're looking forward to have additional members join, and that would be the next slide in here. Well, one thing I want to highlight also, the Alliance signed a few liaisons since its inception. The last one we signed was earlier this month in Shanghai with the Alliance of Industrial Internet. So that's again showing the focus of release 1.1 and its applicability towards industrial internet and IoT applications. Okay, next slide. So again, we have various business cases available on our public website. So I would refer everyone to go to multefire.org white papers. You'll see a couple of research white papers we have from Harbor Research, as well as the full white paper from Randall's company, Wireless 2020, which is the focus of this webinar. Next slide. Again, if you could join, if you're a member company, please go ahead to multefire.org/join. Myself and the executive committee review these on a weekly basis, and we have usually quick turnaround to have membership added to the Alliance. There's a lot of membership tiers, which I'll be happy to discuss with you based on your interest. Okay, Randy, that would be yours. Thanks, Randy. Go ahead.
All right. Well, thank you very much, and good morning to everyone. For those friends on the call, welcome to the call. For those who aren't familiar with Wireless 2020, we're a broadband wireless consulting group. We have been around for about 12 years. Our involvement in the wireless business goes back to before there was a wireless business. We've worked with operators around the world, more than 120 of them, to help them develop technology plans, develop network strategy, develop market plans and overall strategy, look at spectrum strategy. So all the work that we do typically is right at the corner in the wireless industry of technology and business. What we're most famous for is building business cases, and we use what we call the WIROI tool, W-I-R-O-I, Wireless Return on Investment, that helps us really to analyze almost any kind of wireless business case. And so all of that is kind of a great background to look at our subject for today and understand MulteFire not only in the context from a technology standpoint and what that capability that MulteFire brings, what that means for the industry, but also from an economic standpoint, from a business case standpoint, and what that might mean. So so that's kind of what our focus is for today. As we first, to put this sort of in context of what we see overall in the wireless industry, of course, it's a very exciting time as we're looking at companies transitioning from 4G to 5G. We look at the MNOs, and they're really quite challenged to keep up with the continuous increase of Capex to meet the growing demands. In most developed markets, operators are looking at flat to maybe falling ARPUs from each subscriber, so revenue is a challenge. It's a very competitive market, and yet we see the demand for capacity continue to go up, quarter over quarter, and that will not be stopping anytime soon. And so this challenge for the MNOs to be able to keep up with this Capex demand is challenging. And so as all of us spend our lives with our phones in our hands and staring at our screens, and the advent of IOT networks that Mazen was focused on, the need for ubiquitous high-speed connections is always just increasing. IoT networks are invading almost all business processes. And what we see is that 5G is not only an interesting technology, it's a step up in technology. There's lots of interesting things about 5G NR, but also in this transition, there's lots of new opportunity to create different kinds of networks and shared infrastructure networks, maybe selling capacity to the MNOs. There's different ways to use licensed, as the cost of licensed spectrum goes up, there's more and more different ways to use spectrum. There are shared spectrum technologies that are coming on. There are new technologies that can take advantage of unlicensed spectrum, and there's great benefit in that. But and MulteFire is first and foremost a great example of that. And so we look at these new models and the capability to deploy new and different kinds of networks. Alternative carriers could deploy their own infrastructure and own that. New business models that are coming up. Fixed wireless is becoming interesting as more and more connections that are still out there with copper. Copper can't keep up with the is basically reaching end of life and can't keep up with the kind of speeds that are needed for next generation networks. And new strategic private networks can be built for targeted industries, and the kind of IoT networks that we're going to talk about this morning, those will be part of that. So when we look at those trends, MulteFire is really interesting, not only from a technology standpoint, but also it creates interesting new business advantages. So MulteFire, business models, can be created in addition to the strategic technology advantages, and we'll touch on that, but we'll try to focus on some of the business issues. Number one, from a cost basis, and that's always important. MulteFire can take, since it's based on largely on LTE technology, can take advantage of the volume production of LTE networks and radios, and therefore, right when the initial LTE products come out, they'll be at a cost point that'll be very comfortable. The coverage advantage reduces Capex and OpEx for very efficient infrastructure, and again, how this gets applied will be different for some of the different use cases, but that rule overall applies. The use of unlicensed spectrum certainly reduces the initial investment and enables maybe new types of operators and users to participate. Certainly makes it very simple for private networks to be developed with MulteFire. Because it is based on LTE, we can have managed networks that makes the creation of new services, very, very easy, very efficient to be able to do that. And this capability, again, where MulteFire is kind of a global deployment that's not specific to one operator. The idea of having multi-operator networks can reduce costs and enable new business models, and is actually, extremely advantageous to the mobile operators to be able to, participate in shared networks where maybe the economics doesn't really play out for one operator to deploy a network, but if a shared network can be deployed, then that's actually good for all of the operators. Much more efficient use of capital to fill in some of those network areas and be able to support some applications kind of on the edge of the network. So we'll kind of dig into that, and the cases that we're going to look at today are going to try to address some of those advantages. So there's a whole myriad of potential use cases for the paper. We tried to address two different kinds of use cases so we can get a feel for what and how some of those strategic benefits of MulteFire can be brought to the fore. Case one that we're going to look at is we're going to look at a private IoT network deployed in the port of Singapore. And so this will be kind of a classic private IoT case, and very interesting to deploy an IoT network across a very large area. The other, and from a lot of respects, it's going to be kind of at the other end of the spectrum. We're going to look at an enterprise building, and what if we can deploy MulteFire as an in-building solution that's a real neutral host solution that's able to support multiple operators. So those will be the two cases that we're going to look at this morning. So the first one that we'll focus on the private IoT network case. And just some of the key advantages that we can bring here. It is enterprise controlled. First, very important, it's a closed network. It's an independent network, and there's no obligation to the MNOs. If we want to deploy this network, say, and use LTE technology, the first thing that you would have to do is work very closely with the mobile operator that owns that licensed spectrum. So because of the unlicensed nature of MulteFire, the enterprise is able to deploy their own private network. The other thing that's important about it being a closed network, first off, once the kinds of sensors and controllers and receiver technology that we need is available, then this network can be deployed very quickly. We don't have to wait for deployment of the technology in next generation handsets or anything. So that's the primary, one of the important advantages of deploying something, a network based on MulteFire. It's high performance, it's tuned for coverage capacity and applications, and it has the latency built into it. And again, most people are quite familiar with that because of their experience with LTE. So this capability to deploy an LTE-like network in unlicensed spectrum still brings us all of these performance benefits. And it's also flexible deployment and secured. So number one, it's unlicensed spectrum, inherent already in the LTE technology, and furthered in MulteFire is the capability to have managed services and security already built into the network. So all very important issues. So here's the use case, and for those of you who have perhaps traveled to Singapore, as you're flying in, you can't miss it. You know, the Port of Singapore is one of the largest in Asia. It's a sprawling facility over a number of kilometers along the shoreline. There are hundreds of it would take hundreds of Wi-Fi access points that are deployed to accommodate multiple services. Adding more and more PAs increases the interference and decreases the capacity. So, you know, capacity is something that we have to keep our focus on. In this particular case, as I said, this is a large, sprawling complex, so coverage is certainly important. But we have lots of equipment, lots of metal containers that are sprawled around the area, and so you know, having signals blocked and interference becomes you know, certainly quite difficult. So a lot of the capability and MIMO capability of LTE certainly helps with that. You know, we want mobility, but still have you know, low latency and high link stability. So these are some of the you know, some of the requirements that we're going to focus on as we look at deploying MulteFire. So here is you know, this picture here in the middle. You know, I guess does this justice if we can get an idea of sort of the size and stretch of this. It strings out along 16 kilometers of the waterfront along the Singapore Straits. So it's a total coverage area that we're looking at in our use case of about 20 square kilometers. There are 65 berths for docked ships. The port hosts 37,000 ships annually. So we can, you know, do the math and get an idea of how quickly boats are coming in and out of the port. There are over 32 million containers that pass through this port annually. So certainly one of the busiest ports anywhere in the world. So if we were to build this network, what would be some of the key functions that we want to support with this network? And you know, certainly, again, we're using Singapore as an example, but all major harbors would probably have a list that looks very similar to this. We have asset tracking, where for each container that comes into the port, you know, could have a sensor that provides its ID and location so that all assets can be tracked in real time. Losing containers is, as you can only guess, is a near continuous problem. But this tracking capability can make the overall efficiency of the harbor much more effective. More and more, as we would see in many areas, but this is certainly an area where we'd see this, transportation and autonomous vehicles. So real-time communication and planning. So as we have some autonomous vehicles that are driving around the port, that are moving goods, that are moving material, we certainly want to be able to track and operate these from probably from a remote location. So already in the first two, the asset tracking, if we have an ID sensor at each for each container, that's probably a very low band implementation. But if we look at tracking and controlling autonomous vehicles, that's a high bandwidth application. So as we look at what we can do here, we'll probably look at a mix of those. environmental sensors, whether it's weather, air quality, toxic sensors. These will be spread around the port. We want to be able to support those. Communications with arriving ships. Very easy to see that if there's a MulteFire modem that is on each ship as they come, and they come in contact with the harbor network already, they can start making information connection and start to download data and sensors from docking ships. Video and surveillance, again, we'll probably want to have these included as part of the network. Again, that's probably more of a high bandwidth implementation. So as we look at this, we make an estimate of the kinds of sensors that we might include. If we look at, for each berth, we would probably have a number of devices that were associated with that. We've estimated something like 50 devices per berth. The number of boats that are coming in and how many devices are included on each device that we would have to deal with at any one time. If we have each of the containers, and so we would be looking at something like 180,000 devices that would be spread across, and again, some high bandwidth, some low bandwidth, that would be spread across the harbor that we would want to connect to the network. So that just kind of gives us an idea of what the size of the problem might be. So in this particular case, we wanted to compare MulteFire to what if we wanted to do a Wi-Fi deployment. For this example and for the kind of equipment that we would have to deploy, we've made some assumptions around the range that we could deploy, again, taking into account the obstacles and the interference that we might encounter. For the sake of this analysis, these are the assumptions that we have included in the business case analysis for cost and performance. So as we go and we look at this, first we wanted to look at the Capex for deployment, and the Capex looks at, as we can look at each of the stacked bars over here in the Capex case, we're looking at not only the equipment cost, but the cost for setting up backhaul, the cost for installation, the cost for kind of the controllers that we would have to include in the network. And similarly, on the OpEx side, we're looking at the maintenance, the cost for transport, the site utilities, and basically all the support costs to support the ongoing network. And as we look at the case, and again, to support the requirements, these are the results that come out of the YROI tool that we've built the model for the Singapore Harbor. The analysis shows that there's about a 50% cost savings on the Capex, and probably more importantly, 70% for OpEx savings. And there's other savings that we could look that are perhaps important, but maybe a little less tangible. If we want to deploy new kinds of services, this can be done very efficiently and effectively with the MulteFire network. Looking at the security aspects that the MulteFire network brings to us from a cost standpoint. There's certainly savings there, but even those savings probably aren't captured here, because those are perhaps a little less tangible. So all very interesting. So looking at it again, this is a very large IoT deployment. Other kind of large industrial IoT networks, this would probably be fairly similar. But for a use case requiring a large coverage area, MulteFire brings significant advantages. Just the business case analysis tells us there are significant business case advantages brought by MulteFire, the capability to support both narrowband and high band capacity sensors with the LTE aspect of that and the performance that we're seeing. There's no need to add additional capacity based on even the model assumes that there is growth in traffic over the 10 years that the model looks like. We never had to add additional capacity, so this brings lots of additional capacity, and I talked about some of the additional capacity savings. So that is what kind of a large-scale IoT network might look like from an economic standpoint. So now we'll look at use case 2, an enterprise network with MulteFire where we have a flexible deployment. It could be deployed by a building owner. It could be deployed by an enterprise network. It could be deployed by a neutral host operator, maybe that wanted to support multiple operators. Even an MNO could select MulteFire to deploy in an in-building network. The primary advantage there is that would take the burden off of the local macro cell and also be able to support that with a MulteFire network without interfering in the outdoor network. So even a mobile operator may be able to would be interested in deploying a MulteFire network for in-building. With that said, one of the key advantages is a multi-operator network, the capability for a single network of small cells to be able to support subscribers of all of the MNOs, and the MNOs simply don't have enough Capex to be able to deploy networks inside of every building that needs that. So if a third party could come and build a single network that can support all of the operators, that would be a tremendous advantage economically, even for the operators. Have somebody else come in, spend the Capex for them, and be able to support their subscribers. Flexible deployment and security, the unlicensed spectrum, the managed services, and the security that we get from LTE are important here. So just for this particular case, and again, there are thousands and thousands of buildings that need in-building wireless. In this particular case, we're going to look at a 40-story office tower in Midtown Manhattan, 590 Madison Avenue. There's a total of 40 floors. There's about 93,000 square meters of coverage within the building. The total population is about 6,200 people that work in this building. So number one, what are the key functions of the network? We want to support indoor mobile coverage, provide coverage for all of the major MNOs with 5 bars of coverage. And again, this is critical not only for the operators who want their subscribers to have great coverage and great capacity available to them at all times, but for the building owner, typically when someone comes in to rent a space in their building, somebody in the group that's touring the building is looking at their phone, and if they see 1 bar of coverage on their phone, they're probably moving on to the next building to find a building that has better indoor coverage. In our use case, we're assuming that there is Wi-Fi support. It's assumed that all of the tenant offices would be covered by their own enterprise Wi-Fi, and as is typically the case, I think much of the typical daily traffic, the model assumes 80% is going to go over Wi-Fi. So most of us, when we come into our office, our Wi-Fi, our phones typically automatically latch onto the Wi-Fi in our office. So the business case looks at that. This building, as in the case with many buildings, is a multi-tenant building. So to have one operator come in and deploy a network that's likely going to leave 3/4 of the people in the network or who work in the building without good coverage. And so ideally, we would like this network to provide multi-operator support and perhaps deployed by a neutral host, perhaps deployed by the building owner acting as a neutral host. But the assumption here, for the sake of this model, and again, there are many different business models that we can model out with the YROI tool. The assumption here, because this is a very large building, is that the neutral host would deploy the network for the operators. The operators would have a contract with the neutral host to provide support for their subscribers in that building. So those are the assumptions that we have. Typically, the MulteFire savings enables improved economics to support these middle price buildings. And our use case here would be a tier 1 building at 93,000 square meters. Is probably a building large enough that's going to get the attention of the mobile operators. The key is that when we look at tier 2 and tier 3 buildings, as I'm describing here, kind of smaller and medium-sized buildings, it's difficult for the economics of deploying a typical in-building solution to really come in alignment. And so with a MulteFire shared network, again, the economics come in, and perhaps in a medium-sized and a smaller-sized building, now we can be fairly effective at going and deploying an in-building network. So very important advantage that that we could bring here. So the value proposition for the MulteFire network, cost savings both on Capex and OpEx, support for multi-operator small cell deployments. We're able to have a managed network and to facilitate support for multiple operators and enable monetization of the network and the network security. More and more corporate security becomes more of a critical issue here. So in the model, we look at revenue streams, and this is what we see is fairly typical of a building of this size. Of course, as the traffic deployment, as the traffic requirements go up, the revenue model certainly can increase. There can be there are a number of different business models that can be found. Sometimes the M&Os make some kind of contribution to the Capex of the network as it's being deployed. There might be a monthly fee to deliver for each of the M&Os. There could be a usage fee on a per gigabyte basis. Maybe it's all based on traffic. Maybe it's based all on a monthly fee. So there are a number of different business models that could be deployed. But for this kind of network, we could see a revenue stream of more than $2 million over the 10 years that we looked at. And so as we look, we compared a DAS deployment for this network, an LTE small cells deployment, and a MulteFire small cell deployment. And again, the primary difference there being that we only have to deploy one set of MulteFire small cells to be able to support all of the operators. Again, a very efficient Capex deployment, a very efficient Capex deployment, and again, even from the looking at it from the standpoint of the mobile operators, it's great advantage to them to be able to share the cost of that network instead of deploying their own network, even if a building owner would allow each of the 4 operators to deploy their own network, which most building operators don't want to allow them to do that. So as we look at, again, from a Capex standpoint and from an OpEx standpoint, when we look at Capex, we see advantage for MulteFire over both. An LTE small cell deployment on the Capex side is probably some cost savings over DAS, but when we look at the OpEx savings, there's greater savings for DAS over LTE. And again, in both cases, MulteFire has quite an advantage. So in this case, we look at up to 70% cost savings on the Capex side and 70% on the OpEx side. And again, if people are interested in really seeing more details around the analysis, you can either refer to the white paper that Mazen talked about earlier, or you can contact Wireless 2020, and we can give you some more details around some of the modeling and the assumptions. So this capability to go into a building, support a single infrastructure for all of the operators is a major advantage for MulteFire. MulteFire provides significant Capex savings over DAS and significant OpEx savings over small cells. In either case, when we look at the total cost of ownership, MulteFire provides some great advantages for when we're looking at the in-building case over deploying DAS or a typical single operator small cell deployment. So MulteFire is, again, if I hearken back to what we talked about as some of the market trends, MulteFire is an extremely important new technology development for the wireless industry. This capability to have high performance LTE-like capability in an unlicensed spectrum creates new use cases and new kinds of business models. In both cases, and again, I think if we look at most of the different kind of use cases that are being analyzed, MulteFire can drive lower costs, better deployment models, new revenue streams. So all very very interesting. And so providing the economic benefits for anyone who wants to deploy a wireless network. And again, that could be the mobile operators, or that could be new. It could be private networks. It could be new and different kinds of operators. And again, the one thing that I'd be remiss to emphasize is MulteFire is a global standard, and so not only in North America and South America, Europe, Asia, all of these are areas that can really take advantage of MulteFire. So thank you so much. And again, if you'd like some more information about the use cases, refer to the white paper on the MulteFire Alliance website, or if you'd like, you can contact Wireless 2020, and we can help support you with that. So thank you very much.
Thanks, Randall, and thank you, Mazen, as well. We have time for a few questions. So first, I'd like to ask Mazen, which industries are most likely to develop MulteFire first?
Yeah, again, thanks for Randall for a great presentation and a tool. As the MulteFire Alliance shifted from release 1.0 to release 1.1, the focus became more into private LTE-based networks, specifically for industrial IoT applications. So as the use cases that Randall covered, with the shipping port examples, as well as, mining and oil and gas industry. So I would say these are the initial release 1.1 targets from a market perspective.
Great, thank you. And are there any plans for MulteFire certification?
Yes, we actually started the certification program definition and framework about a year ago in anticipation for second half of this year trials and initial plug fest and testing. So when we meet in Beijing next week, we'll have additional work group progress within the certification working group, but eventually we'll have a program announced for end-to-end MulteFire and MulteFire logo program certification. So stay tuned, but I would say we are in the final definition stages of the certification program.
Awesome, thanks, Mazen. A question from the audience. Can you please comment on how MulteFire and CBRS either play well or don't play well together? And additionally, do you see the CBRS band as the biggest opportunity for MulteFire?
Great question, and I'm happy to tackle it as well. I'm also a board member on the CBRS Alliance, so I'm privy on both sides of both alliances. Actually, the MulteFire Alliance and CBRS Alliance did sign a liaison early on. I would say it's either the first or the second liaison agreement between both alliances. I would treat these alliances as very close in terms of concept and the goals of what they want to accomplish. Now, CBRS is focused strictly on the US, so I would position MulteFire as a way for the CBRS use cases to be deployed globally. So if a multinational wants to deploy CBRS use cases within the 50 states, they have the CBRS route, but if you want to take it into international market, MulteFire could work as a good complement to that. So from that perspective, both alliances are driving private LTE network kind of deployments. So we share the same use cases at that level. Now, as folks are aware with CBRS, they'll be deploying LTE-based solution, not MulteFire, and that's based on market timing and the dynamics of the CBRS timing in the state.
The one thing that I'll, if I can, the one thing that I'll add to that, and again, both of these technologies sort of fit into this model that I described of technologies that enable, you know, different kinds of deployments and maybe different kinds of business models. Of course, you know, CBRS, again, as Mazen said, is focused here, is focused in the US and is based on a shared spectrum concept, which is certainly very interesting and something that may be repeated in other areas and maybe other spectrum bands. And MulteFire, you know, is in an unlicensed band. And so those, while both of them are intended to make deployments and make spectrum available to others outside of having others who, you know, who have large spectrum holdings like the major network, the mobile network operators. You know, that's one of the key differences.
Great, thanks. Another question, Randall. What are the biggest pain points with wireless connectivity that that MulteFire overcomes?
So the first one is that the first one that I'd start with is what we were just talking about. If people want to look at a wireless deployment, the first thing typically that they're wringing their hands about is, you know, am I going to need to spend, you know, a couple $1 million on spectrum or maybe hundreds of millions of dollars of spectrum, you know, to be able to, you know, before I even think about what the rest of my business case looks like. So number one, the unlicensed capability, the unlicensed spectrum capability of MulteFire, A, addresses that, and B, the other thing is that for a number of the use cases, like the Singapore case that we were looking at, a lot of these are local, as would be the case with most sort of private IoT networks. These are localized deployments. So typically, if you had to buy spectrum, then, you know, you'd have to buy it at the very least for a region, if not a national license. And so from that standpoint, you know, that becomes extremely important. The other is the capability that it brings to deploy kind of closed networks, and especially in these, what I described in my presentation. So, you know, a lot of these use cases to be able to, you know, deploy a network that's closed, you know, that becomes a key reason where someone would really want to look at MulteFire.
Great. And do the assumptions on cost per access point have any reference source? And if not, on what basis do those assumptions are they made?
Yeah, so is part of our work. You know, we work with most of the major vendors. We often are asked to participate in RFPs for our operator clients. So for Wi-Fi, for LTE. We, often are quite familiar with kind of the latest pricing trends. So we've tried to apply some of that information. Also, as we were developing the models, we were working closely with the Wi-Fi Alliance members, including the manufacturers that are members of the Wi-Fi Alliance, to help give us guidance on the pricing that was used in the model.
Great. And also, Randall, where will we see neutral host deployments?
Well, that's certainly very, a very interesting and what I would say a very topical question. And as we look at sort of key trends in the industry, and we look at the challenges for the mobile operators as I laid it out, most of the operators today largely look at themselves as network companies, and that the key asset of their company is their network. And yet you see this challenge that I described of, the challenge for the mobile operators with this, to try to keep up with this ever increasing capacity demand, 20% per subscriber per year, 40% per subscriber per year, pick which traffic growth estimator study it is that you would like to look at. But we certainly know that it's increasing and increasing by a lot. So one can more and more, the operators can't afford to invest in every rumpled edge of the network. And for our sake here, it may that may include in-building networks. They cannot put a network inside every building that needs improved in-building coverage. They cannot cover all of the capacity demands as they grow, maybe in the urban core. They may particular coverage areas. Very challenging for an operator to deploy a network in kind of these economically sort of questionable areas. They certainly would like to have perfect coverage everywhere, but really an ideal solution for the operators is in these sort of marginal economic areas. If a third party could deploy a network that can support all of the operators, that would be economically viable, where it wouldn't for one operator. And so, I think that most of the time to date, we've thought of neutral host networks as indoor networks. And I think what we'll start to see more and more is that model will even start to bleed out into the outdoor networks.
Awesome. Thank you so much, Randall. Mazen, what spectrum band is MulteFire on?
Well, initially, the initial release 1.0 was targeted for the 5 gigahertz band. So that's a global 500 megahertz, similar to LAA and ELAA. Now, as Alliance started working on release 1.1, other spectrum bands were identified globally. So we have actually summary slides where we listed these. Now for release 1.1 specifically, oh, you have it there, great. So we have listed additional bands that could be targeted, such as sub 1 gigahertz, 1.9 regionally, as well as 2.4 when it comes to eMTC and NB-IoT applications. I know 3.5 is listed on this slide. That's more of a technical solution available, but as I mentioned earlier with CBRS, LTE will be deployed there in the state.
Great. And Mazen, does the enterprise in a closed network request want to manage themselves, or do they need management help of the network, assuming the core is on-prem?
That's a great question. Actually, the way the architecture of MulteFire is designed, it enables a flexibility. So the answer would be it depends. You do have options. Now, depending on the size and scale of the enterprise specifically, some of them would like to manage themselves. Some of them would like to work with the managed service providers. So the flexibility is there. It's more of a business relationship and related to cost as well.
Awesome, thanks. Will MulteFire adopt 3GPP's 5G NR unlicensed standard when it's released?
Sorry, I didn't hear you. What was the question?
Yeah, will MulteFire adopt 3GPP's 5G NR unlicensed standard when that's released?
Right. So we had that roadmap slide earlier as well. So right now the Alliance is waiting to see the 3GPP progress when it comes to 5G NR and a licensed band, including the standalone mode. And based on that, again, as we worked with the LAA and ELAA with the release 1.0 and 1.1, we'll be working, again, in a supporting role based on what 3GPP is doing from that perspective.
Okay, great. Well, I think we have time for one last question. So do you guys maybe want to just wrap it up on a few points each?
Sure. Yeah, so I think that as we look at what's happening in the industry, MulteFire is a very important technology, kind of coming along at a very interesting time. The capability both to be an enhancement and another tool in the toolbox for the operators is extremely interesting, while at the same time it creates both from a technology standpoint and from a business model standpoint, it creates really interesting new possibilities for deploying different kinds of networks. And so we'll be following the progress of these deployments and what and how people are deploying these different kinds of use cases very closely.
Great. And again, we have a lot of resources on MulteFireAlliance.org website. We tend to be very public in all of our materials, white papers, as well as webinars. So that's a great resource there. I know we got a lot of questions to field within the last 10 minutes or so. But please reach out to the MulteFireAlliance.org. We do have resources in place to support you. And again, if you'd like to join, there's a link there for joining the Alliance as well.
Yeah, thank you so much. And I'd like to conclude the webinar with that. And thank everyone so much for your time today. Really great questions from the audience as well. And we will be happy to follow up with those questions afterwards. Thanks everyone again so much, and have a great rest of your days.
Thank you very much.
Thank you all. Take care.